All right, time for another DraftPhysics.com, debatephysics.com also, but we can't find anyone capable of making a physics argument, where there's a disagreement and the two sides, haggle, using vocabulary to make their arguments. No, we don't have anything like that. Unless you want to say flinging insults is the same as a debate, but not really. You have to do the physics thing, and the physics thing sort of requires that you do this thing. This. You usually have to draw it. Physics is a little complicated. Some of it. It's mechanical things moving. So sometimes you got to draw it, show it. But anyway, so we have something interesting. Somebody left a comment about have you been watching Dr. Fatima videos? And Fatima. Anyway, and no, I haven't. So I had to go see what the hell they were talking about. So anyway, so this is a physicist. Okay, she's done her, she's done the hard work, gone to school, done a little bit of research crap and all this stuff to get the extra degree. Not taking any of that away, not at all. And it's a girl. Okay, it's not supposed to be a big deal, but it sort of is a big deal. When women can, finish the job, so to speak. I mean, lots of women go into sciences. Not too many women come out a scientist, kind of thing. But anyway, great. She talks great. She looks great. Except for, maybe I'll throw in the except fors, because why not? I got so little to lose. Does it really matter? So anyway, she's doing the whole edgy thing, really nice. She's got pretty good slick graphics here. She does the green screen thing. I don't know if this is a green screen or not. It's damn good if it is. Okay, I mean, the plants really fool me. I had one of these elephant ear plants when I was a kid. It's my favorite pet. I actually took it with me. I grew up in Louisiana. I took it with me when we moved north at 6 years old. I needed my plant. It was my whatever you call that. When people need an animal to help them, it was my it was my help plant. And I finally killed it. I had it for 40 years, and somehow I killed it. It was really disappointing. But anyway, there's a lot of tragic stories in my life. Just horrible, horrible. Anyway, so yeah, really, all really done well, nicely done. Blah 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 blah. I got a couple of little criticisms. Just, no big deal. Okay, so she's doing the physics thing, but she's mostly talking about physics in a way. So I haven't gotten that deep into some of the stuff yet. But she's a very good talker. Okay, so she's got the argument rhetoric thing down. She seems to be able to handle herself, all that kind of stuff. So we'll play some of this. It's, this I don't like. Gravity is a social construct, and that's okay. I mean, that's all kind of clickbaity, like, what are you, a flat earther or something? I mean, what the hell is that about? So that wasn't too good. And so we're at the history of gravity, and so she's basically pointed out that, Galileo did this much, and then Newton did this little extra bit, and then she's going to start talking about how, Einstein did something else, and it wasn't in the right direction. Okay, I mean, Galileo and Newton were going the right way, and Einstein took you all the way back to the cellar, frankly. Too silly. Turned something real into some sort of bent geodesic, some sort of mathematical nonsense, like there's some sort of math formula that got bent somewhere, and that's why there's gravity. Really too stupid. But anyway, so maybe we can get her. The whole point of me making this video, I guess I should get right to it, is to see if she's up to defending physics, and the arguments about why physicists believe the nonsense they believe. And it's nonsense, right? Like the opening graphic. I mean, does she, as a physicist, do you really believe your physics? I mean, do you really think it takes 100 times the energy to spin a motor 10 times faster? Do you really believe that crap? I mean, do you really think 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet? If you had to choose between the two things over your head, you would choose. Well, you think they're both the same, so you can't make the choice. I'll hit you twice with one of them. Okay, so which one are you going to choose if I'm going to hit you twice with it? Um, I mean, all right. Well, we'll see. We'll see if we can get anywhere. You know, probably, obviously not, because as she sort of points out in her personal video, which I did not re-watch all of, because after a while you just don't care. Um, she's doing the teaching thing. She's a teacher, and how to teach people things. And to me, I'm a big fan of telling them the truth. So if you're going to teach somebody something, you should tell them the truth. That's a good way to teach. So anyway, we'll play this stuff, and we'll see where it goes. I haven't seen where it goes yet. It has a little map of where it's going, but it doesn't sound too good. Okay. So it's going to be history of gravity, and then we're going to get into dark matter, which she's probably going to say is crap, which is good. So that's something on her side. But then she's going to probably defend some other kind of nonsense, so it ain't going to matter. So it's interesting for that alone. Anytime a physicist kind of points out that some of their physics might be crap, it gives you at least some hope. But the fact is what they really need to say is one piece of crap probably means there's two pieces of crap, and if there's two pieces of crap, there's probably a whole lot of pieces of crap. All right, so let's play some of this. Charming.
This Galilean formulation, Newton's law of universal gravitation wasn't quite as universal as he thought.
All right, so of course it was, and it wasn't missing anything, and the whole Mercury thing, okay, is sort of messy, all right, in terms of the fact that Mercury's orbit's got a little bit of this precession in it, which isn't a big deal, and it doesn't mean that anything Newton said was inaccurate. It just means that what Newton was arguing is a stationary sun. Okay, I mean Newton's position was the sun's not itself precessing. So obviously, when you're comparing the other planets with a non-precessing sun, they're far enough away that it's not enough of an influence to affect anything. And it's only because Mercury is so close to the sun that the sun is precessing, just a little bit. The sun's vibrating a little bit. It's moving. It's not in exactly the center of the solar system all the time. Its center of mass is swirling around a bit. There, problem solved. So, I mean, there's lots of ways you can understand that the precession of Mercury is not that fantastic or that irregular, because it is so much closer than all the other planets. I mean, Mercury's like all by itself, and then the other planets are out here. Okay, so it really does provide you an opportunity to create some circumstance that only affects Mercury and really doesn't affect anything else. So there are rational explanations.
For example, in the 1800s, astronomers had measured the orbit of the planet Mercury so precisely.
So this was a big thing for Eddington and Einstein. So the trick here is that Einstein didn't answer the question voluntarily. Eddington put it to him. Okay, so Eddington's the guy who was a big Einstein fan, okay, and who made Einstein famous by saying, okay, that light is bent twice as much by gravity, because he proved it with his really terrible experiment. All right, so we'll talk about that too. So it's the same Eddington. So the same characters in physics are the whole story of physics. So there's really the accusation is there's like 45 people on planet Earth that decided what the truth is, and they're all going to just tell us what the truth is, 45 people. And it's not a democracy. Nobody else gets to talk, really. So they just decide for us. Everybody says yes or no to what the 45 people say, and then we're all stuck for the rest of our lives. We're put in chains or house arrest if we dare say, I don't think that's right.
that they found it to be inconsistent with what Newton's law of universal gravitation would predict. So they figured that there has to be another planet in closer to the sun.
See, that's what they figured, right? I mean, so I would think there was some of them who probably did maybe suggest, well, if the sun's center of mass is itself processing, then Mercury would process also because it's so close. I'm sure somebody probably said it, but nobody liked him, so nobody paid any attention.
Spoiler alert, there was no such planet. It wasn't until Albert Einstein developed his theories of relativity at the start of the 20th century.
So the truth is, it wasn't in his theories of relativity. It wasn't something Einstein found the answer to ahead of time. So he was obliged to do it. So Eddington basically said, well, look, if you're going to convince anybody of this crap, can you explain Mercury? And so then Einstein, with a few of his German mathematician friends, spent 8 months or something contriving the math. So this was math made after his paper, contrived for the specific purpose to answer this stupid question. And the first answer was different than the second answer. So let's just be sure that if the first eclipse that happened in whatever it was, 1918, I think, or 1917, if that wasn't interrupted by World War I, then Einstein would have been proven wrong, because Einstein said then that gravity only bent light the same amount as mass objects. Now, obviously, I'm saying none of it. It's okay. There is no bending of photons. Silly stuff, really. So that's the irony of, the whole fate of physics is all dependent on all this little mush. So if they had successfully done the experiment 2 years before, Einstein's answer would have been wrong. And, but he changed the answer, and Eddington found what Einstein was looking for, but obviously he found it under the circumstances that can be pointed out, where Eddington says in his own journal, his diary, okay, I'm expecting 10,000 stars per glass slide. I only got 1,000. Terribly disappointing, okay? And then he says, I wouldn't stake my life on these results. So we know the data sucked. I mean, 10% of the data quality. You're going out to try to do something really difficult. That is, you're going to go out and say, I'm going to see a fly at 25 feet. 25 feet, I'm going to see a fly on a table. And then somebody pokes you in the eye. Yeah, come on, it ain't going to happen. So it's really suspect experiment. Never repeated beyond the margin of error. Never even attempted with the perfect 12 noon eclipse over North America, and no professional astronomer tried the experiment, and never attempted from space. So 50 years in space with 400 times better resolution. So look, her major was in this astrology crap, this looking into space shit. Do you really think that's a plausible truth, that they never even occurred to them to attempt the most famous experiment in physics, and they never even attempted it from space? I mean, as Einstein himself pointed out, right? This is something Einstein even pointed out in conversation, in letters. You could use Jupiter, okay? Because, from Earth, you can't. But from space, with 400 times better resolution, Jupiter's in the ball game, and it doesn't have any say in Jupiter. Einstein was suggesting Jupiter without talking about doing it from space. But the point is, the difference is the Sun and Jupiter. The big difference is you can get a lot closer to the surface of Jupiter because it doesn't have big giant flames flying off of it. So you don't have to go way outside the corona of the sun to do Jupiter. All right. So leave us continue.
that Mercury's weird orbit could be explained. The TLDR of relativity is that the rate at which time passes can be altered by extremely high.
Oh, just too silly. So yeah, you break all this Newton stuff. So Newton said, yeah, look, you might have observed there's a forward, a back, an up and down, a left and a right, and time is a function. It just ticks off because there's no instantaneous. Nothing's happening instantaneously, and because nothing's happening instantaneously, everything's happening at some slower speed. And so, yes, we're in a slow averse. Okay, it's not a fast averse, it's a slow averse. So everything is happening sequentially because nothing is instantaneous. But you can't. There's no warping of time.
Speeds or strong gravity, time is relative, so everything else.
Says you. It's not. So nonsense, silly. I don't even know what it could possibly mean. Time's relative. Relative to what? Time? Well, it doesn't make any sense. Sorry.
Else's too. Relativity is trippy and weird and too.
Why don't you just say it's we've made a big convoluted funny artistic picture, and it doesn't look like anything. Well, I mean, some people might see one thing, some people might see another thing. That's sort of one of the things, the little tiny criticisms. She's got the bone in their nose thing, which I just don't go for that whole stuff. Don't get it. I don't. I just don't get it. I mean, why would I put a blob of crap like a Hitler mustache? I could wear a Hitler mustache, or I could draw one on my face. Is it going to help somehow? I don't think it'll help any. All right, and then this big, giant microphone. Just kind of shrivels the guy down a little, and just, well, I can't compete with that, so the hell with it. It just takes all the fun out of it. So if that's what you mean by relativity, is that everybody has a different point of view. Yeah, everybody sees something different. But it can't change the description of the reality. So even if we're looking at it from a different point of view, it really shouldn't change the physical, factual, explainable reality. Mirrors behind books. Interesting. Anyway.
Complicated to explain here, but the important thing that you need to know for our purposes is that we were able to make...
See, this is the part that I just don't like. We were able to. So you and who? What? Jack? Frank? Joanne? You and Joanne figured it all out?
Make even more precise predictions about gravity with it. And many...
So again, there's nothing else that comes with it. Einstein's package comes with nothing. It doesn't come with anything. And especially anything more precise, okay? Because they just keep using things like they'll talk about GPS or something. And the truth is the GPS numbers are, really fudgy. So, they think because they adjust the clock at all, that means it's precisely following Einstein's formula. When no, it isn't. They don't figure out what Einstein's formula says, then turn the dials to what Einstein says, and it matches perfectly. No, they adjust it to make it work. They don't worry about the formula. So it's all kind of just mush.
Experiments have supported Einstein's theories of relativity.
So yes, that's what they just keep telling us, and they really don't. They just support certain ideas like you can break atomic clocks by giving them velocity, which sort of makes sense because we know there's certain ways you can break the decay rate of any isotope. So I can just put more isotopes next to each other and I'll change their decay rate. So I can change how an atomic clock works by just putting a little tiny of radioactive material near it, and all of a sudden it'll change the rate. So the idea that velocity would change the rate, or the idea that gravity would change the rate, and that's the more significant player here is gravity. So I mean, all of this, yes, it's physics, so it's a little more complicated. So you have to recognize that, the part of Einstein's theory is that gravity, is doing this bending of the geodesic warp thingy. And the fact is you can sort of understand that the clocks that are broken are the ones that have been slowed down, by relativity, as if the clocks are moving too fast, are the ones on Earth. The clocks on Earth are the ones broken. And the ones in space that are going 20,000 miles an hour around the Earth, they're the ones not moving too slow. So it's us that have been time dilated. And it's because we're in gravity. We're in heavy gravity. And what happens in heavy gravity? See if the physicists can understand the concept. Because no other physicists so far, they don't get this simple argument. But you're moving up and down in gravity. And as you move up and down, it's like a basketball player bouncing a basketball. The basketball player might be going 5 miles an hour, but the basketball is obviously traveling a lot more distance. Okay, so its linear travel of the basketball is huge. And so its real velocity is gigantic. So when you're bouncing going 1,000 miles an hour up and down, you're actually going a lot faster, velocity-wise, than the satellite that's going 20,000 miles an hour. Because of the actual distance you're traveling, because you're a least. Okay, you're not traveling a straight line. Probably goes over the physicist's head, unfortunately. Yeah, who knows? We'll see.
From Eddington's observations of gravitational length.
All right, so we know that Eddington's observations are completely suspect, unrepeated experiment, really, really bogus, and the whole idea of it even, just the whole idea of the lightest thing in the universe, that is something like light, moving the fastest, and is almost, is fluffy. I mean, I don't know how you say it, but it's so unmassive. And to say it's bent by some special reason twice as much. So an electron doesn't bend as much as a photon. Why would that be logical to anybody? How could they even imagine that being logical? But the idea that no force interacts with any other force, that any stuff going the speed of light does not interact with some other force going the speed of light. So all this stuff in the force category that's not matter doesn't interact with itself or anything else going the speed of light. So why would we think light is bent by gravity when it's not even bent by light? You can't bend light with light. You can't bend light with magnetism. You can't bend light with an electric field. You can't bend light. And it's just, they really don't have any evidence that you can bend it at all, let alone twice as much. And all of the astrological pictures from space that show the little phantom nonsense, none of them make any mathematical sense. Einstein admitted the Einstein ring would be impossible to see because gravity is a shitty lens, frankly. It's not bent the right way. So there would be one little tiny line of photons that would have the right gravity, and the line would be so thin that you'd never see an Einstein ring because the line would be so thin. It would be so few photons because you go in a little bit, the bending is too little, and you go out a little bit and the bending is too much. Just the opposite of a viewing lens. Too much bending going in, too little bending going out.
During a solar eclipse in 1919 to measurements of stellar orbits around the supermassive black hole Sagittarius star in the middle of our galaxy made just a few years ago.
Okay, and so again, that one's made out of so many composite blah blah blahs that you could argue that can be almost anything in there. And again, it doesn't show light bending at all. So you're showing us, she went through that pretty quick, but they have a picture of the stuff swirling around the black hole, and there's no evidence in any of that swirling around that any of those photons were bent. So the two pictures really aren't consistent. They really don't say the same thing. All right.
So we're definitely right this time. As powerful as this set of theories is,
So again, it's not definitely right this time. So again, she's sort of mocking the physics is wrong, and yet she's going to hype parts of physics that don't have any evidence either. All right, so she already in this video said the magic trigger words for me. 9.8 meters per second per second. Well, she said second squared. That's right. She even said the per second squared thing. And it's like, no, that's not what Galileo discovered. He discovered 9.8 meters per 1 second. And that's what Newton discovered, or affirmed, was 9.8 per 1 second. And yes, maybe at the equator it's 9.85, and maybe someplace else it's 9.79. But it doesn't matter. It's per 1 unit of time, 1 second. It's not seconds, and it's certainly not anything called a second squared.
It has shortcomings. Most famously, the relativistic construction of gravity is incompatible with quantum mechanics.
All right, so no, it's also incompatible with Newton's bucket experiment, frankly. So all the way back in Newton's time, they were already discussing this possibility that the whole view of the universe is some sort of magical waving hologram or something, or some kind of bullshit like that, like there is some sort of real relativity. And so much they were having that conversation that Newton felt the need to actually go to the trouble to say, let me explain it to you. Okay, so I'll explain it to you real quickly. I wanted to make this a video. I just hadn't gotten around to it, so this will give me the opportunity to just play with the idea. So Newton, he's so damn smart. So he figured out a way, okay, of illustrating this idea that relativity is a crock of crap. So you take a bucket, okay, and you're just going to, so this is the bucket. You're looking down in the bucket. This is the wooden sides. Now the idea is let's just say the bucket was a glass and you could see through it. What's really going to happen here is that when you spin the bucket, this is going to happen. All right, the water is going to push out to the sides as you spin the bucket. And we know it's going to happen because the water molecules are going to stick to the wood, all right, and they're going to slowly but surely be accelerated. And they're accelerated all in straight lines. A piece of wood moves this way, and the water moves this way, and then it moves this way, and then it moves this way. And it's all really straight line vectors. The water's all trying to go straight, and it has to be forced to keep going in a circle. But anyway, so you start giving the water. It starts going, it spins on the outside first, and then because the water molecules are all sticking to each other, it starts pushing all of them and giving them all a vector, an arrow vector of velocity. So I have this arrow going the wrong way, isn't that cute? All right, but it's all straight line vectors anyway. But the point is the water all starts to turn, and the turning means it's all just trying to get out. Okay, it's all out, out, out. Okay, out. And obviously the bucket stops it from going out, so that's why it goes up. And as it goes up, obviously this goes down because it's running out of water because it put the water up here. So anyway, and so the simple argument Newton made, that's just so fucking smart of him, is that now if I was the bucket, how can I tell, that what I'm doing? Okay, whether I'm moving or not moving. And if I look at the water, it'll tell me the answer. It'll tell me because the only other alternative is that the whole universe is spinning. Right? So let's just say these are my only two choices for bucket spinning. Either the bucket is spinning or the whole universe is spinning the opposite way. Right? Now, if this whole universe was spinning the opposite way to give me the illusion that my bucket was spinning, there would be absolutely no reason for the water to do this thing up here and down here. There's no reason for it. It can't happen because there's no change in the overall gravity of the universe. It's the same stars, the same amount of light, the same amount of stuff is gravitationally affecting the bucket. So there's no way I can possibly imagine this happening inside the bucket. So clearly I know the bucket's moving. If the water goes up, the bucket's moving. I mean, and it's pretty rock solid. Because again, even if you imagine the whole universe is doing the moving, it won't make the water rise. The universe, by spinning, can't create more gravity. Just like by spinning, it wouldn't create more light. If you could spin the whole universe, and the Earth just stood still, didn't rotate anymore, didn't do anything, just stood still, and you spun the whole universe, you can't make the whole universe make more light. And you can't make the whole universe make more gravity. Because frankly, the two forces are pretty much the same thing. All right. Yeah, that's probably enough for her to get. She's smart. Don't get me wrong. Girl's smart. She can talk. Knows shit. Okay, so she should understand. I mean, it's still a rock solid argument. No one's touched it. Okay, I mean, Mach was superficial. I mean, no one's touched Newton's argument and defeated it. Where was I? Play button. That's it.
Which is arguably the other most successful set of theories to come out of the last century of physics.
Oh, barf. Oh, sorry. Throw up. Vomit. Oh, all right. Never mind.
Both of these paradigms make extremely robust predictions in their own regime.
Whatever. So that's just jargon, blah, blah, blah. That almost sounds like a Wikipedia page. Blah, 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 blah. We just talk up ourselves.
Relativity describing interactions between the most massive objects like stars and black holes.
So that's really not the rule. So the rule is there's one universe. So that's probably another thing like, none of the physics teachers will say this very simple thing. They won't say it. They won't say it. It is funny. But the universe is just one universe. It's just one. And it's got electrons and protons in it. And then force that's pushing the electrons and protons. And electrons and protons are in empty space. Nothing. They're just in positions. And it takes time for them to go from one place to another. And that's the only universe. And everything that happens in this universe, even the silliest things that happen in this universe, they all have to happen. The electrons and protons have to do it first. They're the first universe. They're the only universe. They're the one in the actual space. And this emergent big stuff, only does what that little universe says it has to do. If it doesn't happen in your little universe, it ain't happening in the big one. So that's a key thing in physics to understand. So if somebody wants to do science and physics, I would suggest the key thing to understand, one of the first things you need to understand, is there's only one universe, and it's electrons and protons. They're the elemental matter, and whatever they do turns into what big things do. Really big idea. All right, back. So there's a little line here she has written. It's kind of funny. It says, "I meant what said. Fight me." She's playful. Anyway, she's got great hair. Anyway, it is distracting. I'm sorry. Yeah, this whole, See, that's what she's talking about here partially also. She's talking about discrimination and all kinds of other things, all kinds of social parts of doing physics. And yeah, that's the problem, is that our human personalities get in the way all over the place. I mean, we're all takers and exploiters and take advantagers, and then we get pissed off. Like, I'm going to be making 35 videos ragging on Wikipedia, because they treated me badly. They I got dissed, and fuck that, right? I ain't eating that shit. And so we get that kind of crap goes on. And then somebody fucks with us, and then you look like somebody who, hurt my feelings, and that's just good enough to trigger me, and then I'm going to hate you for no real good reason because you look like somebody who hurt my little feelings, blah, 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 blah. And all that's sort of important, but I'm not terribly interested in that. So yeah, I'd love to have a physics conversation, though, about all the physics never proven. Never even close to proven. Like, they never even put anything on the evidence table. They just made the whole story up. It's just a big story on the evidence paper. Bugs Bunny, Punch Daffy Duck, and the blood that came out of Daffy Duck's bill, and that spilled on Tweety Bird, and Tweety Bird got AIDS and died, and Tweety Bird's mother was all upset. They tell a whole fucking stupid idiotic story, and it's all crap. Okay. Continuing. Let's play the video.
And quantum mechanics describing interactions between the smallest things like particles and light waves. But they break down if you...
So, light waves, yes, you're going to lose points for that. It's just baby talk. There's no waves. Just baby talk. Oof.
Try to consider them together because they each make different assumptions about the underlying nature.
Now, they don't make any assumptions. The scientists make assumptions, okay? So they make up fake experiments that never took place. They can't draw the patterns correctly. I mean, I just did a whole bunch of two-slit stuff, so I won't do that again. But on the website, debatephysics.com, there's a bunch of 5-minute videos that go covers some of this stuff. And, no, it's just all bullshit.
Reality. In quantum mechanics, causality is statistical, almost random seeming. The rate of time passage is static.
All right, so I don't even know what that means. Causality is almost random. Now that's just not true. I mean, I think we all get the idea that it's cause and effect. Okay, that there's always a cause, and that all you do is find it. So, I'm sorry, it's just the reality. You can always find it. If you really think about it, you could find out, if some guy has a fetish for feet or something, or some kind of bullshit, you can find out why. Just ask enough questions, do enough looking through the microscopes and the telescopes, and you can find the answer. All right, time is static. I don't even know what the fuck that could mean. Oh. So this part isn't thrilling me too much. I have to admit, I'm not too... don't like these kind of charts. This isn't the kind of drawing I want to see.
And the universe has some baseline resolution, as if it's made out of really tiny pixels.
All right, so that's the part where, they got good evidence for that one. So that one makes sense. I mean, you certainly know the matter bits are kind of pixelated in that there's just really nothing smaller than electrons and protons. And, this quark crap and all that other, fuck that. The electron and protons are the real players. They're the thing creating charge. Charge is creating everything else. I mean, come on. It's just not that difficult.
Relativity to work, however, causality is necessarily deterministic. One cause can yield only one effect. Time.
I really didn't think when she said gravity in the title that she was going to talk about relativity. I mean, it's just such a, it's such a non-answer to the question of why things move into each other. And and the big joke is they can't get away with using that kind of nonsense to explain charge. They can't just say, well, it's a bent geodesic and this is a positive geodesic and that's a negative geodesic. It doesn't, it's just too made up. It's too nothing as an answer. It's just a magical force.
Is relative, like we said before, and the universe is continuous. There isn't some minimum size or mass that...
Oh, I don't know if Einstein would go for that at all. So I don't think Einstein believed that the universe was continuous. So that's... I don't think so. I really don't think so. So I think that's a stretch. That's not Einstein's general relativity.
Things can be. This is a great opportunity to point out the problem with thinking of scientific knowledge as either right or wrong.
There either is or isn't. That's really the way to think of it, okay, is that those are what you're seeking. You're seeking the complete, finished answer. And the real argument is when are you allowed to jump to a conclusion, to say we have established this as a truth? When have we provided enough evidence and tried the case and it's just beyond reasonable doubt, right? That's the standard. It should be some sort of reasonable doubt. We have beyond reasonable doubt. So I could say it's beyond reasonable doubt that water's wet because we invented the word water to describe what wet to describe what water is. So that one's really easy. And then we go on to the rest of these things. We establish it as a fact, and it really has to do with trial evidence. It really has to do with how much evidence do you have? Do you have fingerprints and DNA, and confessions and witnesses and, how much evidence do you have or how little do you have? obviously all the conclusions they've jumped to about quantum mechanics and this relativity crap is all jumped to on tiny shreds of evidence, really weak, foggy pictures of Sasquatch. And they've declared that we must believe in Sasquatch, even though the zipper is showing on the photograph. Even though there's cracks and fissures and good reason to say, no way, you still haven't explained Newton's bucket. What are you telling me this for? Newton didn't say 9.8 meters per second squared. Why are you saying it?
A naive, if not kind of understandable, reaction to these conflicting theories might be to say, well, if they contradict, one of them must be wrong.
Or both of them are wrong, or everything you're doing is wrong, because your standards for science is wrong. I mean, the clear violation here, right? I wish the clear violation is the jumping to the conclusion. You have to be disciplined. You have to be like a Darwin. You have to go out and collect evidence for decades and organize it all and make your really good case. You can't just sit there and say, well, GPS, and say, oh, that's all you need. No, you need more than that. All right, and they've never required there to be more than that. Again, not repeating the Eddington experiment. I mean, just the fact that they're claiming no one tried it from space seems preposterous. And so the obvious answer is they tried it and it didn't work. So they just presume they did something wrong, or you just can't do it from space, or some kind of crap, but they just walked away. But it seems clear they must have tried it and it just doesn't work. But the truth isn't, the truth doesn't matter. It's the story that matters. They can't fix things like positive and negative because now it's too ingrained in all their bullshit. All of Maxwell's equations have to be reconfigured. You have to turn everything upside down to fix something that you know is broken. Amperage isn't going in a different direction than the voltage. It's not. And yet you've configured your formalizations that are broken. And you just don't, it's too much trouble to fix it. So you don't fix it. So obviously there's going to be circumstances where it's clear what you're saying is wrong. And it won't require that you turn physics upside down to fix it, but you don't even want to try. Even if you have to bend it a little bit, people don't even want to do that much work.
But the reality is that they both work. They both...
blah, 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 work. To do what? None of them invented the blue LED, good example. Lots of things were invented, not by any theory, okay, but by the hard work of finding out what works better, what works a little better, what works a little better, what works a little better. All right. That's what created something. All right, this mysticism about how the theory gave us anything. So just show me where, if we didn't believe in 1/2 mv squared, show me the place where the airplane crashes. Show me where the lunar module fails to land on the moon because we don't believe in the fake formula.
Both have predictive power, but each one has a particular context in which its predictive power is reliable.
Oh yeah, or even anywhere close to the truth. So again, they never test any of this stuff. They never really do the experiment and really see if it comes out the way they're saying. So again, the 1/2 mv squared overtly tells you that if you go bowling, you should use a lighter ball because by throwing it faster, you'll gain this huge advantage in the amount of energy you can hit the pins with. It's an absolute lie. It don't work. Okay, that's the fact. And then it's this whole 100 times the energy to spin a motor 10 times as fast. I mean, everybody knows who has a dimmer switch on light bulbs, that's not true. It doesn't work. It's not how reality works. The prediction is wrong. It won't require 100 times the energy to make a motor spin 10 times as fast.
In fact, it doesn't really make sense to call earlier theories of gravity wrong either.
Well, of course it doesn't make sense because they got such right answers all over the place. So there was absolutely nothing wrong with Newton's theory. And again, the explanation could be as simple as the sun is precessing. That's it. That answer does work. Okay, it's an absolute fact that I can give the sun just enough precession where it screws up Mercury's orbit exactly the amount that gets screwed up, and none of the other planetary orbits are affected because it's such a tiny amount of precession. I mean, it's a fact that'll work.
Newtonian gravity works for certain contexts. Galilean gravity works for certain contexts.
It works for all contexts. Momentum works for all contexts. So again, I contend that momentum will always give you the right answer. So show me where momentum will do you wrong, will end up crashing your car. Show me where that's true. Or this is just kind of bullshit, isn't it? Yeah, you don't have any evidence of any of this new physics being real. It's all theoretical for a theoretical matrix that doesn't really exist. You don't use it ever for anything. I mean, as NASA points out, they don't even open Einstein's book. They couldn't care less, okay, about what Einstein says, because it doesn't do anything that matters.
Hell, even the ancient Greek models that were barely more sophisticated than a cat's understanding of gravity works in certain contexts.
I don't know what that would even mean. I mean, the earth, fire, water thing was pretty bad. Whatever you're saying there. I don't know what you're saying there. Clearly, Archimedes knew a lot of shit. Clearly, the ancient Egyptians were pretty good at figuring shit out and how to do something. So they understood what tipping points are, right? Tipping point, that's a big one in talking about electrons being expelled from atoms. I mean, understanding the concept of a tipping point and understanding that, if you put energy in as an object's moving in the direction that you're pushing, that you'll add energy to the system. And if you put the energy in when it's moving in the opposite direction, you won't be able to add any energy. I mean, those are all really, that stuff still works.
I mean, the cat got over the thing, didn't it? Sometimes the cat knowledge is enough. Each model accounts for the knowledge that was available at the time and was iterated on as our new discoveries and ideas illuminated our ignorance.
Oh, brother. So whatever all that is, and then a jump cut. But anyway, I mean, come on. The whole argument is that we all know that you can take steps forward and then take a step down. I mean, there's no movie that does the Dr. Ehrlich thing. His magic bullet, the invention of chemotherapy, and in trying to discover a cure for syphilis, right? And the idea is he's trying to control two factors, and the fact is that the factor of brain damage versus killing the microbe, and so you're trying to balance those two things, and the staircase is this. I mean, the staircase is, you make a victory, and then your next improvement ends up putting you back down the cellar again. And you got to work your way back up again. And you're just, it's a battle to keep going in the right direction. And my argument is, like the stock market or something, that this down from Einstein was a deep, deep well of stupidity. I mean, it was a big mistake. It broke all of the mechanics of physics. I mean, it started with Leibniz. It started with the stupid mv squared and then the A equals mc squared. The squaring of velocity was such a bad idea. I mean, it has no dimensional rationality. There's absolutely no reason you could even imagine a squared velocity. It isn't a square area. A velocity area. A cube of velocity. I mean, it's too nonsensical. But those are big mistakes.
And it's easy to look at this history of gravity and feel like we're coming closer and closer to the truth.
I don't even know how anyone could even observe anything even close to that. You just talk more and more nonsense. You're not getting closer to anything. Where in my lifetime have you, as physics, said anything to improve its statement beyond saying, well, there's this magical geodesic that does exactly what light does in the reverse, right? I mean, all this stuff does the inverse square law. Newton gave you that much. It's kind of obvious that it's just radiation in reverse. So instead of you radiating light, you are pulling, okay, or something else is pushing into you, and more goes in than comes back out. And it's kind of obvious for me to say, well, in hindsight, I can look at it and say, oh, gee, it's so obvious that don't we all see it? I mean, how can we miss what's really happening? That the Earth is molten. Obviously, the energy that's going in is moving a bunch of electrons and protons, and therefore the energy is being used a little bit. And so what comes out is weaker than what went in because the energy got used moving all that crap around. Back and forth, really. It didn't move it around anywhere. It's just going like this. It's going a bunch of pointless motion. Motion nowhere. And that has used some of the force's energy. It's so simple. It's such a simple explanation.
But in reality, it only seems like that in hindsight. When you learn a lineage of increasingly successful theories in a physics class...
Oh dear. So a lineage of completely, sequentially better theories. And again, there is none. There is no lineage here. I mean, they can't do lever experiments right. I mean, things that are 2,000 years old. I mean, 2,000 years ago, they knew you put something twice the distance on a stick, it's going to go twice as fast. These people are telling you, no, it won't, because somehow the inertia will stop it from moving, because it can't be free energy, right? If I have the same momentum and I have twice the velocity, then I made free energy, so that can't happen. So something has to happen to break the simplest device in antiquity, the stick. So again, bullshit, there's progression here. You've gone backwards, you've gone in negative perceptual directions and ruined your vision, ruined seeing what it is. You've smeared the reality, and you can't see through that smear.
Or science documentary, you generally don't learn about the false starts and failed ideas that were necessary.
Oh, you get all this propaganda about the experiments that never took place, the photon detector experiments. I mean, all the hype and the bullshit that has nothing to do with reality. We've proven, we established, we decided, we will tell you. The 70 people that run physics will tell you what to believe. Because it's too complicated for you people. You're not smart enough. You're not as smart as us.
To get us to where we are today. So to complicate matters a bit, we're going to shift gears into a modern problem in astrophysics that continues to illuminate our ignorance about gravity.
All right, this will be scary maybe. Okay, no, it's dark matter. Okay, that's safe.
Dark matter.
Good, okay. Completely made up. She's going to say it. I hope she's going to say it. I have some faith that she's actually going to say it's completely made up shit. Not a shred of evidence. Just made up. We need to fix what's broken. Well, what's the easy way to fix it? Well, we just could sweep it all under the rug somewhere. Do you have something called a dark matter where we can have all the errors disappear? Yeah, I don't really like this stuff much, but whatever.
So I'm going to go ahead and hazard a guess that most of you have heard of dark matter before and are at least vaguely aware of it as something that probably exists.
Oh, brother, no way. Oof, I've heard it. I said, what the fuck? They can't be that desperate. You mean they're really going to try to sell this silly theory that there's some sort of magical... It's an invisible gremlin theory. That there's invisible gremlins in the universe and they fly to different locations and create fake gravity, but they don't do anything else. They don't reflect light and they don't make their own gravity and they don't do any of this and they don't do any of that. They just fix your mathematical errors. I mean, no. Oh, goddamn. Oh, pain. The pain. All right, so I'm going to take a little pause so their physics, right? The physics I want her to explain says crazy, wacky shit, okay? And what it says is that if I take this battery and I lift it up and I put it on this scale, all right, that I have 1 unit of energy trapped in this scale. And then if I do exactly the same thing, I take exactly the same weight object, I do exactly the same thing, and I slide it on the scale, I have 4 units of energy now, 4. So this is 1 unit of energy, and this is 4 units of energy. They believe that. Okay, that's what their physics says. All right, they live by it though. They breathe that kind of nonsense in every day and say, yeah, that makes sense to me. Yeah, it doesn't make sense. No, it's really dumb. So that's about as dumb as dark matter. I mean, theoretically, I mean, it's about as dumb as dark matter. I mean, it's about as dumb as Leibniz's axiom that for 1 pound dropped 1 foot is the same force as 1 pound dropped 4 feet. It's as dumb as that. NASA knows better. I mean, NASA knows those two things don't hit the ground with the same force. So why are they pretending this crap is true?
As another astrophysical lady YouTuber who I get compared to a whole lot has explained.
Oh, it's kind of a weird comparison, frankly. I mean, she's okay, but you're a lot more stylish, I have to concede. yeah. But anyway.
In a recent video of hers,
dark matter is not a theory, it is an observation.
For our purpose.
Oh, an observation. My God. Oh, God. Oh, shit, that hurt. Man. God, don't do that. Ooh, an observation. What? Oh, God, that's funny. Anyway.
This is today. I'm only going to explain one of these observations as.
Oh, brother. So what? They're really going to talk about this fake crap. I mean, at least the whatever Sabina Hassenfelder has actually conceded that some of this is just made up. That they have a problem. Their math is broken, and they just fixed the math, but they're fixing it with pixie glue. I mean, it isn't really going to work in the real world. There's no pixie glue.
The mental foothold for my broader arguments, but I will refer to some of these other observations a little in passing, so if you want a more solid baseline explanation of the full set of observations.
Oh, brother. So these are not observations of any, like in the real world observations. This is like when they said they photographed the donut. It's not a photograph. Come on. This is all synthesized mush. So this is, microwave background radiation. No reason to think it wouldn't have hot spots and cold spots and blah, 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 blah. So this is just all mush.
Go check out her video, if for no other reason than to hear the dark matter rap.
Oh, brother. Oh, God, I wish you wouldn't do these things. Lame. Incredibly lame.
Is it red? Is it home?
Iconic. So what is this observation that we call dark matter? The graph I'm going to use to explain this is called the rotation curve, and it shows how the speed objects in orbit around something changes as they get farther away from that thing. So if we were to make a
So again, it just really depends. Look, I mean, there's just no reason for these physicists not to understand that a galaxy is fundamentally different than a solar system because of the fact that there is a Vulcan on the other side. There's an Earth and a Vulcan, and then there's a Pluto and a Vulcan, and then there's a Jupiter and a Vulcan. Okay, big Vulcan. So there's all kinds of stuff on one side and the exact same mass on the other side. So galaxies function entirely different because in a theory, the galaxy can spin based on the gravity of the arm on this side opposed to the arm on this side. It doesn't need anything heavy in the middle. So galaxies are fundamentally different in terms of the gravitational equation is so much more complicated because of how much gravity you have on the outside versus the weight on the inside. The solar system has a minute, tiny, 1 in a trillionth amount of mass in the planets, and the sun is the big giant thing. And a galaxy has a ton of mass, in its arms, and maybe, half the mass in the center. Who knows? So it's a completely different equation. So of course you can't use the same formulations. You can't use the same math and say, oh, it works the same way, because it works completely different. And then the arms themselves have a ton of gravity in them. motion because of the changes in the density of the number of stars. Oh, it's the multi-body problem. I mean, it's really hard to calculate gravity, when you have more than one object affecting something. It gets really complicated and when you're talking about billions of stars, you shouldn't have the expectation that the crap in those arms is going to move the same speed as you would predict for Pluto. It's not the same circumstance.
Rotation curve of the solar system, for example, this axis would be each planet's distance from the sun, and each point's height would tell us how fast the planet is orbiting. And we have a trend. The further the planet is, the slower it orbits, because the force due to gravity, which is what's driving the orbit, gets weaker with distance. But it's slightly more complicated than that. The mass that gravitationally drives the orbital speed isn't just the thing in the center, it's everything inside the orbit. But because the sun is so much more massive than even all the planets put together, the difference in...
Yeah, exactly what I just said. And the difference is that obviously a galaxy is really different than that, because guess what? The galaxies aren't a million times brighter in the center than they are on the outside and that kind of stuff. Some of the galaxies look kind of even peaceful. They almost look like hurricanes, with the eye of the storm being almost, quiet. Almost quiet.
Mass inside Mercury's orbit and the mass inside Pluto's orbit isn't that important. So the variation we see in this rotation curve is mostly just because of the changing distance.
R squared.
If we were to make the same graph for a galaxy rather than a solar system, we would expect the curve to look a little bit different because the mass isn't as concentrated at the center. The further you get, the more stuff you're orbiting, so instead of the graph dropping off quickly, it holds up for a while. But once you get to the edge of the galaxy where there's not that much more stuff being added, the graph should begin to drop. Or at least that's what we would have expected.
Yeah, so that's what you're expecting and that's if you understand whether or not the galaxy is actually expelling material or collecting material. And you really can't say. I mean, I don't think you can really make that argument that the galaxy is collecting. You could make the argument that the galaxy already collected and now it's expelling. That somehow the gravitational constant, let's say, has changed over the trillions of years or whatever. And you could argue as the universe ages that these galaxies are basically just doing this. They're subtly going in and out based on how much energy gets caught up in gravity and how much energy is free in the universe. And as the energy goes from being trapped by the matter to being released in supernovas, for example, or something, that gravitational constant subtly changes. And the galaxy goes from going in to going out. And if it's obviously getting bigger, then you would expect the suns on the outside perimeter to be going pretty fast because they're being allowed to move away. They're being allowed to move straight away.
It turns out, when we measure the speeds of the furthest out orbiting stars and gas and galaxies, they're going much faster than we'd expect, as if there was a lot more stuff inside those far-out orbits than we can see. And
so that expectation would only be valid if you understood exactly that the very fact that maybe the whole galaxy doesn't have sufficient gravitational energy to pull anything in, okay, and that the whole thing is expanding.
That difference between the rotation curve we predict based on the mass of the matter we can see in the galaxy and the actual rotation.
All right, and so they're going to say it's because there's a big ring of fake matter just happens to be in the right location. So if we could see the dark matter, it would be this hard, bright ring, okay, right around where they would need it to be. It wouldn't be anywhere else. It would just be where they want it to be. So there'd be these big solid rings of hard gravity, in these silly locations for which there could be no explanation for why it would collect there. None whatsoever. No theory to defend its location. And the only way they get away with it is because it is invisible and you can't see it, and therefore they can put it anywhere they want.
action curve we get when we measure how fast things are moving is what we call dark matter.
Why would you call it dark matter? You don't even know if it's matter, so shut the hell up.
The term
Exactly. Yes, just shut the hell up. Yes, I wish that was the theme. Prove it or shut up. Provide something like evidence or shut up. Don't tell me I have to believe the shit. Don't tell me this is the only reasonable conclusion that could be reached by any organism that has a neurologically functioning brain. They must believe this crap. No, they mustn't.
dark matter is simply a label for a particular way in which our understanding of the universe is wrong. It is exactly this wrong, and that wrongness is what dark matter is. It's not a theory, it's a set of observations. And
Okay, I don't even... Why even say it? Why even say it? It's not observations. The dark matter isn't an observation. It's a contrivance. It's a fake, made-up solution to something not matching. It's an eraser, and you've erased reality and just decided, well, if I use this fake theory, I can draw it wherever way I want to. I can go where I want the line to go. I can draw the horn on the unicorn. What the hell does this have to do with an observation? It's really irritating. She's irritating me now.
this is one of them. Now, everything I've said so far is just kind of categorically true. This is the prediction that our currently accepted models of gravity expect, and this is the measurement we see when we try to test those models. Neither of these things is really up for debate. I mean, I could probably make it up for debate, but I won't. But even though what I'm about to say next could be found in any intro astronomy textbook, I want to mark this point as the end of me sharing facts about dark matter and the beginning of me sharing theories about dark matter. There's a difference, and it will make more sense as we go.
No, it won't. You're just talking shit now. Okay, you talk some shit. Now you're gonna talk double shit. Okay, got it.
What have you made?
Woo, double woo. Religion. So instead of religion, you're gonna talk religion.
Mixing metaphors if I said we're now crossing the event horizon? Whatever, I'm a physicist, not a poet. So the prevailing explanation for why these two curves look different is because there's some invisible stuff in galaxies. And if this were to be the case, there are two things we could confidently say about it. First, that it doesn't interact electromagnetically. It doesn't emit light or absorb light or reflect light and is therefore completely undetectable in imaging.
Right, so it's an invisible man. I mean, come on, you're going to go to court with your invisible man theory. Okay. And somebody should believe it. No, nobody should believe it. Nobody. Everybody should say, oh, come on, that just sounds like you're trying to get the guy off. You're not trying to do physics. You're not trying to get the right answer. You're just trying to get this asshole out of that fucking electric chair.
That rely on light coming from an object. Or according to some theories, it doesn't interact electromagnetically much, hence dark. And second, it does interact gravitationally. Because it's causing these gravitational effects on orbits, it must have mass, which means it must be some kind of matter. Thus,
but it doesn't obey any of the other things' gravity. So again, like I said, if they actually drew where they're putting it, it would look so out of place. And you would say, well, why wouldn't the dark matter move right into the center of the galaxy? Why would the dark matter be out here if it's so dense? It couldn't possibly be out there if it's dense.
Dark matter. Stuff with mass that we cannot see. Hard to see stuff. And that's a fine idea. But there's kind of a big hole in it, and that's that we don't have any real idea of what it actually is. There are a ton of different models for what dark matter is, but none of them explain the observations completely.
I mean, what's the point? So now she's going to say, well, we'll do you the favor of having a conversation about what the invisible man is made out of. And that's why he's invisible. So we'll do a bunch of theoretical work and explain to you why the invisible man is invisible. Yeah. We'll do that for you. I mean, we'll never come up with a rational answer, but we'll just do that. Yes, we're working on it. We're working on the why is the invisible man invisible question. Oh, fuck. Sorry, I'm really starting to feel the weight of the stupidity. It's like some kind of dark matter. Yeah, the stupidity is like some kind of Dark crushing matter. It's just crushing stupidity. Crushing stupidity. Crushing.
Theories model dark matter as a kind of particle, like axions or gravitinos, or
Oh.
what somebody very cleverly named weakly interacting massive particles.
Oh, and that's
Feels like
exactly what
projection.
this is all about. Wimpy shit. Wimpy, wooey bullshit. Okay, so I'm just going to get more and more depressed. So the hell with it. Okay, so that's my introduction. So, hi, Dr. Fatima. Fatima, not Fatima. Fatima. And, that's a very big microphone. Anyway, that you're stroking. Anyway, okay. Don't get distracted. Don't be distracted. It'd be really nice to have a physics conversation about all the fundamental premises, the whole wave particle thing, the whole there isn't really three-dimensional space, there isn't really space itself isn't something, that it's some sort of relativistic bullshit that you can wormhole your way through it, that kind of crap. I mean, all those conversations are just, I think, yeah, I can make conventional physics look ridiculous if given the opportunity, frankly, because it is ridiculous, and it's all a slander of Newton. Newton did so much, gave you so much, and you threw it all in the toilet. He stood on the shoulders of giants. He did a great thing, and then, the big fat ass of modern physics just sat on it all and squished it all. The big fat-headed bullshit, ego physics of the 20th century. A bunch of little silly people that got to tell the whole world what they have to believe. Ridiculous. All right, so enough of a video. Till the next time and such. When I again... I'm sorry, I would like to, look, I made that nice polite video to that last guy. And I put the nice response video on his video. Nice, look, response video, blah, blah, blah. Deleted in less than an hour. I mean, what the fuck? I make a polite video saying, hey, this guy seems kind of interesting. Maybe he's smart. Maybe we can have a conversation. And what does he do? Just deletes me. It's just so depressing. Interacting with these personalities on the internet. These egos. Ugh. So anyway, we'll see what happens. I mean, she's not a celebrity yet. She seems strong. She can defend what she's saying. She's in the game. Let's see. We'll see what happens. So anyway, till the next time and such. Strange video. I have to admit, strange video. But, in some ways, aren't they all? Yeah, I mean, they've just been getting stranger. That's what I'll say. I mean, it's just getting so ludicrous. When I actually had a physicist admit, in the Wikipedia thread, two physicists, well, two scientists, they were, who knows what their real degrees were in, but two scientists said they actually believe it takes 100 times more energy to spin a motor 10 times as fast. They actually believe that's true. I mean, that's just so depressing. All right, anyway. Till the next time and such, that's all I'll say. Charming. It was charming to meet you. Till the next time and such.